On Young's double slit experiment. Here this time we are going to look at the shift in central maximum. Suppose you have a pair of coherent sources S1 and S2, and there is a screen, and at a distance, let us say d, and the distance between these two sources small d. We found that light from here goes here, light from here goes here, and this distance, this point is P, and we said the total distance traveled by this light extra is this. This was, we consider this as theta, so this is d sine theta. That means S2P minus S1P is actually d sine theta. So what is it? What if we introduce a glass plate of thickness T? So what will happen to this point, or what will happen to the path difference? So here you need to understand one thing. Suppose there is a glass plate of thickness, let's say T. So when light travel from here, suppose let us keep two light sources here. By the time it travels from here to here, because in this medium light is always slow, it travels this much of distance in vacuum. So let us call this distance in medium, this distance in vacuum. So we know refractive index mu is equal to velocity in vacuum by velocity in medium. Velocity in vacuum is distance traveled in a medium by time taken. Here in the same time, what is the distance traveled in medium? Distance traveled in medium by t. So cancelling these two, we know that refractive index mu is distance in vacuum divided by distance in medium. Here t is time. We have also taken t as thickness. Since time get cancelled, you don't need to worry. So distance in vacuum, this tv equal to mu times distance in medium. This is what we are finding. This is called equivalent distance in vacuum. So suppose if light travels a distance of t in medium, so dm here is equal to t. So the equivalent distance in vacuum is mu times t. So now how we calculate the path difference? The path difference delta is S2P minus S1P. Here S2P, so from here to here S2P. From here to here, the distance in vacuum is S1P minus T, because this distance is in medium. So from here to here S1P, you subtract T, that is the distance in vacuum. So additionally, there is a distance thickness T. So I'll just do it in a straight line. So this is the thickness T. This is S1, this is P. The total distance is S1P, of which T distance is in medium. So the equivalent distance in vacuum is distance in vacuum equal to S1P minus T plus this distance of T. The equivalent distance in vacuum is mu T, so it is plus mu T. So here actual path difference after introducing the glass plate is S2P minus of this distance S1P minus T plus mu T. So S2P minus S1P plus T and minus mu T. So delta S2P minus S1P, we already know it is d sine theta. Here let me take minus out, minus of mu minus 1 into t. So actually if you take t, 1 minus mu will come, because I have taken minus, so it is this thing, mu minus 1 into t. Okay, so the total path difference here, delta equal to d sine theta minus of mu minus 1 into t. So we already know that theta is very small. In that case, what about d sine theta? So we already know that d sine theta is this, and then from here to here, this is also theta. So this distance is y and this distance is d. So here tan theta is approximately equal to sine theta. When theta is small, tan theta here is y by d. So it is y by d. So I'm substituting that. So the path difference delta equal to d into y by capital D minus mu minus 1 into t. If this delta is n lambda, it is a bright fringe. So just multiply all of it. N lambda equal to y into d by d minus mu minus 1 into t. Just multiply by d by d up here. When you multiply this, dn lambda by d equal to y minus d by d into mu minus 1 into t. So the position y is equal to dn lambda by d. When this goes to the other side, it is plus d by d into mu minus 1 into t. So for the central maximum, n will be equal to 0 for the zeroth maximum or the central maximum. So y, the shift in the central maximum equal to n0. So d into 0 lambda by d plus d by d into mu minus 1 into t. So the shift in central maximum equal to d by d into mu minus 1 into t. This is a very useful relation, but at the same time you can also express this in terms of the fringe width. You know that fringe width is equal to lambda d by d. So d by d is there, only lambda missing, so multiply and divide by lambda here. So shift in the central maximum is d by d. I'm just multiplying and dividing by lambda into mu minus 1 into t. So this lambda d by d is beta. So the shift in central maximum, let me call delta y equal to beta by lambda into mu minus 1 into t. It's a very useful relation even for CBSE problems and NEET problems. So today we have discussed the shift in central maximum is this and this, and know that here lambda is not involved. Here we are writing this in terms of lambda, but here when you look at this relation, there is no lambda here. So know that shift in central maximum does not depend on lambda. Shift in central maximum does not depend on lambda, does not depend on lambda or the wavelength. That's an important thing. So shift is also independent of the fringe width, so it does not depend on lambda, and shift is small for, shift is same for all colors. Since lambda is not there, shift is same for all colors, same for all colors. And another thing to note is shift, where if n is the number of fringes, you can also just write the shift, how much is the shift, by dividing by the number of fringes. So delta y, the shift is d by d into mu minus 1 into t. Suppose if you want to know the number, how many number of fringes has been shifted, so just have to divide by beta. So the shift in number of fringes will be, beta is actually lambda d by d, correct? So these two will be cancelled up here. So you can say that in place of beta only lambda d by d is done here. So d will be cancelled, this d will be cancelled. So mu minus 1 into t by lambda. So the shift, so I'll just summarize all the formula. So actually the shift in the central maximum is d by d into mu minus 1 into t. The other way of writing the shift is beta by lambda into mu minus 1 into t. And the shift in terms of number of fringes, shift in terms of number of fringes. How many fringes has been shifted? Number of fringes. So shift in number of fringes. Number of fringes. Okay, equal to nu minus 1 into T by lambda. Shift is same for all colors. It is independent of the wavelength, and this is the three important formula regarding the shift in the central maximum, and the other part we'll discuss a bit later.